Good morning, students. Today we will study one of the important and interesting topics of physics, that is heat. Heat, what is heat? Heat is an invisible form of energy which causes the sensation of hotness or coldness on us. Heat is a form of energy that can be transferred from one object to another due to the difference in temperature. It can be produced in many ways. For example, when we rub our palms together, they get heated because of the heat produced on rubbing. When we burn a piece of paper, then the heat is produced. Now, what happens if you hold a hot cup of tea in your hand for some time? How do you feel? What do you feel? You feel warm. This is because of the heat energy that flows from the hot cup to your hands. Similarly, what happens in case of ice cube in your hand? How do you feel? You will feel cold. This is because of the heat energy that flows from your hands to the ice cube. Thus, we can say that heat is a form of energy that flows from a hot body to a cold body. Heat is mainly received on earth from sun. We feel hot if we sit under the sun. We cannot see heat energy, but we can feel it. Thus, heat can be defined as the invisible form of energy which causes the sensation of hotness or coldness in us. Now, let us have a video to understand the various sources of heat and the direction of flow of heat.
Hello students, can you imagine how cold the earth would be if there were no sun? The sun is the earth's main source of heat. Only a little of the sun's heat reaches the earth. However, this is enough for life to exist on earth. Other sources of heat are fire and electric heater. In this lesson, we will study about heat and its measurements. The sun, burning fuels, electricity, and mechanical work are sources of heat. Let us perform an experiment. We keep tin or aluminium sheet out under sun and touch after some time. We then place the same tin or aluminium sheet inside the house. Touch the sheet after some time. In the first case, we feel hot, and in the second case, we feel cold. Let us prove through another experiment that sun gives heat. Use a magnifying glass to focus sunlight on a piece of white paper. At the position where the sunlight is focused, the paper becomes hot, starts to turn brown, and soon bursts into flame. Thus, the heat from the sun makes the paper burn. Man can generate heat by burning wood, coal, and gas. Wood, coal, and gas are called fuels. Fuels burn in machine to make them work. A motor car runs by burning fuel. An aeroplane flies by burning fuel. Electricity also gives heat. Man uses electricity to cook the food and to work the machines. Heat can also be produced by rubbing two things together. This is by doing mechanical work. Rub the palms of your hands together. What do you feel? You will feel that it is hot. The ancient man generated fire by rubbing two stones. You must have held both ice and hot cup of coffee. Why is it that in one you feel cold, while in the other it is hot? When heat energy from our body flows out rapidly, we feel very cold. This is the case when we hold ice. Ice on the palm gives a sensation of cold because Heat from your body flows out of your body to the eyes. With this heat, the ice on your palm melts. When the heat energy flow from outside into our body is rapid and more, we feel very hot. This is the case when we hold cup of coffee. The heat from tea or coffee flows to tea to the hand. Thus, it is the flow of heat energy which determines the cold or hot. Students, let us perform an activity to understand the concept of direction of heat flow. We place a glass of hot milk in a dish with cold water. After some time, milk gets cool and water gets warm. Both milk and water come to lie at the same temperature. Direction of the flow of heat is from hot to cold. Now we will learn
Units of heat. Since heat is a form of energy, the standard unit of heat in SI system is joule. One of the other units to measure heat is calorie. 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of substance by 1 degree Celsius. Here the substance we will take is water. The bigger unit of heat is kilocalorie. 1 kilocalorie is equal to 1000 calorie. The relation between joule and calorie is 1 calorie is equal to 4.186 joules. Let us come to another topic of the same chapter, that is temperature. Before discussing the temperature, let us discuss some of the cases. What happens if we dip our finger in hot water? We say that water is hot. If we touch an ice cube, we say that it is cold. In case of fever, our body becomes hot. In all the above cases, we cannot tell how much hot the water or the substances we have taken is. Temperature is something which tells us the degree of hotness or coldness of our body. We have already read about the flow of transfer of heat from a hot body to a cold body. We can say that the heat transfers from hot body to a cold body when there is a difference in the temperature. If two bodies are having unequal temperatures, and then they are brought together, the temperature of the hot body decreases, but while that of cold body increases. This happens till both the bodies attain the same temperature. The two bodies are then said to be in a state of thermal equilibrium. So we can define finally the temperature as the physical quantity that tells us the degree of hotness or coldness of a body. SI unit of temperature is Kelvin. Other units are degree Celsius and degree Fahrenheit. Now let us understand more about temperature via an animation.
Now we will learn the concept of temperature. Temperature is the measurement of hotness or coldness of an object. We say that water from fridge is cold and milk is hot. How much cold is water? Is it cooler than ice? How much hot is milk? Is it hotter than boiling water? Obviously, for this we need a measure to know about coldness and hotness of a body. A hot body is at a higher temperature than a cool body. When a substance is heated, its temperature rises. On cooling, the temperature comes down. Degree of hotness or coldness in a body is described as its temperature. The table shows the difference between heat and temperature. Heat is a form of energy. Temperature is a measure of heat energy level. Heat energy raises the temperature of a body, while the temperature decides the direction of flow of heat. Heat flows from a body at higher temperature to the body at lower temperature. Heat is measured in joules. Temperature is measured in degrees Celsius or Kelvin. Now that we have learnt about temperature, let us look at the device used to measure temperature. It is called a thermometer. The most common use of thermometer is to measure our body temperature. Such a thermometer is called a clinical thermometer. A clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end filled with mercury. Outside the bulb, a small shining thread of mercury can be seen. A clinical thermometer reads temperature from 95 degree Fahrenheit to 107.6 degree Fahrenheit. The normal temperature of human body is 98.6 degree Fahrenheit. The clinical thermometer is also known as a doctor's thermometer. Precautions to be observed while reading a clinical thermometer are as follows. Thermometer should be washed before and after use, preferably with an antiseptic solution. Ensure the mercury level is below 95 degree Fahrenheit. Read the thermometer keeping the level of mercury along the line of sight. Handle the thermometer with care. If it hits against some hard object, it can break. Do not hold the thermometer by the bulb while reading it. Let us now discuss laboratory thermometer. A laboratory thermometer is used for measuring the temperature in a science laboratory. It is similar to clinical thermometer but is long and narrow. A laboratory thermometer reads temperature from -10 degrees Celsius to 110 degrees Celsius. Let us now measure the temperature of hot water kept in a beaker. Take a laboratory thermometer. Immerse the bulb of thermometer in hot water. See the shining thread of mercury moving up in the thermometer tube. After some time, the mercury thread will stop rising and stand at one place. Read the temperature on thermometer tube, which corresponds to the top of mercury thread. This is temperature of hot water.
Measurement of temperature. An instrument used for measuring temperature is known as thermometer. We are most familiar with liquid thermometer. Thermometers in which liquid is used as thermometric liquid are called liquid thermometers. Mercury and alcohol are the liquids usually used in thermometers. There are various types of thermometers. These are classified on the basis of purpose of their use. First of all, let us study about the laboratory thermometer, which is more commonly known as mercury thermometer, as the thermometric liquid in this kind of thermometer is mercury. This is the most common type of thermometer used in a laboratory. It is having a very fine glass tube called capillary tube with a thin glass bulb at one end. This bulb is fitted with a shiny liquid called mercury. Mercury is easily seen in capillary tube because it appears as a shiny thread. The other end of the capillary tube is sealed. The capillary tube is protected by a thick glass tube called the stem. The stem of laboratory thermometer has graduations usually marked in degrees from -10 degrees Celsius to 110 degrees Celsius. When the bulb of thermometer is placed in hot water, the mercury rises up in the capillary tube. The level up to which it rises gives the temperature of the hot water in degree Celsius. Now let us study about clinical thermometer, which is more commonly known as doctor's thermometer because it is used by doctors to measure the person's body temperature. It is usually graduated from 35 degrees Celsius to 42 degrees Celsius. This is because human body temperature can vary within this range only. In this kind of thermometer, there is a slight bend or kink called constriction in its capillary tube just above the bulb. This constriction prevents the mercury level in the stem from dropping even after the thermometer is taken out from patient's mouth. Thus, we can take our time to read the temperature accurately before using the thermometer again. It must be washed with water and then jugged till the mercury level falls below constriction. Let us have a look on both the thermometers whether the mercury thermometer or the laboratory thermometer has a kink or not. We can clearly see here that clinical thermometer, that is more commonly known as doctor's thermometer, has a bend or a kink known as constriction. Effects of heat. There are various effects of heat. The first one is change in temperature. On heating a substance, its molecules gain kinetic energy. This causes a rise in the temperature of the substance. When a substance is cooled, its molecules lose heat energy and the temperature falls. This rise or fall in temperature is due to the heat gained or lost by the substance. Second effect of heat is change in size. On heating a substance, the molecules move faster and the space occupied by them increases. This causes the increase in overall volume of substance. Thus, heat caused expansion. Similarly, on cooling a substance, its volume decreases. The increase in volume of a substance due to heating is called thermal expansion. The decrease in volume of a substance due to cooling is called contraction. The third effect of heat is change in state. Matter exists in three different forms: solid, liquid, and gas. When a solid is heated, it changes into liquid, and on further heating, it changes into gas. Thus, heat causes a change of state of substance. Conversely, on cooling, a gas changes into liquid and a liquid changes into solid. There are different processes which take place during the change of state of a substance. These can be melting, freezing, vaporization, condensation, sublimation.
The object may expand or contract in size. A substance may change its state when heated. For example, water changes into water vapor on heating. We observe a change in temperature on heating. On heating, temperature rises, and on cooling, the temperature comes down. In nature, the sun energy brings about a change in temperature. The days are warm, while the nights are cool. Summer is hot, winter is cold. Matter exists as solid, liquid, and gas. All the three states of matter expand on heating. The expansion of matter depends on the temperature through which it is heated. In this case, when we heat this plate, the higher the temperature, more is the expansion. Expansion of matter also depends on the size of the material being heated. The longer the plate or bigger the ball, more is the expansion for the same rise in temperature. The nature of the material being heated also plays an important role in expansion. For example, copper expands more than iron for the same rise in temperature. Liquids and gases are fluids. They expand on heating. Expansion in gas is very large as compared to solids or liquids. Let us look at some practical uses of thermal expansion of solids in daily life. The iron rim is fitted in bullock cart wooden wheels by heating. When the metal cools, it holds the segments of the wooden wheel firmly. A small gap is left between the rails of a railway track, where the two rails are joined with the help of a fish plate. The gap is left to allow space for the expansion of rails in summer. Let us now look how heat affects the change in state. On heating, a solid changes to liquid and a liquid changes to gas. Conversely, on cooling, gas loses heat to change into a liquid and a liquid loses heat to change into a solid. The temperature at which a solid melts to change into its liquid form is known as its melting point. Melting point of ice is 0 degrees Celsius. The temperature at which a liquid starts boiling and changing into its gas state is known as its boiling point. Boiling point of water is 100 degrees Celsius. Perhaps you have observed that when a stove is lighted in the kitchen, the air inside the room becomes little warmer. If this air is allowed to come out through an open window, it gradually cools down. The metal stirrer left in the cooking bowl becomes hot. These examples indicate that the bodies at higher temperature lose heat and consequently their temperature falls. When bodies gain heat, their temperature rises. There is a mutual exchange of heat between bodies at different temperatures. Flow of heat takes place in a particular direction, that is, from bodies at higher temperature to bodies at a lower temperature as water flows from a higher to a lower level.
Heat and the bad conductors of heat. Substances which allow heat to pass through them easily and quickly are called good conductors of heat. All metals are good conductors of heat. However, the ability to conduct heat varies from metal to metal. Silver is the best conductor of heat, followed by copper, aluminium, and iron. Bad conductors of heat. Substances which do not allow heat to pass through them easily are called bad conductors of heat or insulators. Wood, glass, plastic, rubber, and paper are bad conductors of heat. Ebonite and asbestos are insulators or bad conductors. Liquids and gases in general are poor conductors of heat. Mercury is an exception. It is a good conductor of heat.
Jeff's family is having a nice time at the park. It is indeed a good day to have a picnic. His dad brings a grill and starts to barbecue chicken on the grill. Jeff runs to his dad to see if the barbecues are already done. He holds a metal skewer but immediately lets go because it is too hot. His dad uses oven gloves to hold the metal skewers without feeling the heat and shows Jeff the barbecues. The metal skewers are examples of materials that allow heat to flow. These materials are called heat conductors. Metals are good conductors of heat. The oven gloves do not allow heat flow to take place. These materials are called heat insulators. The non-metallic oven gloves are good heat insulators. Heat conductors are important in our daily lives. Cooking pans are made of metal to conduct heat easily and help cook the food faster. The base of the iron is made of metal so that clothes can be ironed quickly. The mercury inside the thermometer expands and contracts rapidly with slight changes in temperature. Heat insulators also play important roles in our daily lives. The walls of an icebox are made of polystyrene to maintain the coolness inside the box and prevent heat from entering the box. The handles of cooking utensils are made of wood or plastic so that they will not get too hot, allowing us to hold the utensils without getting burned. Woolen clothes and blankets trap a layer of air. The wool and air prevent heat loss from our body, thus keeping our body warm.